motorsports, providing workshops, training, and building vehicles. We have worked extensively with 150 plus engineering colleges, built student teams, and made them participate in any national level or international level events. Along with that, we have got our active engagement and active role in the development of electric vehicles. So we provide consultancy services and the design consultancy services to electric vehicle startups. We also provide manufacturing solutions to those teams. We've built vehicles, we design vehicles, and this is what we have been doing for the last 6 years and 7 years. So with my understanding of electric vehicle industry in India and my extensive work with some of the foreign clients, I would be sharing my insights into this industry and how you people can contribute into this thing. So before moving up to this thing, I want you people to please share a bit of your insight, like what your expectations are, what you want me to speak in this session. Anyone can take the lead. Okay, then. So I will also be speaking about the government policies in India. Okay, in which you people as a student can also integrate with those people and build the products. So we will be taking up that particular thing here. Anything else?
Also, sir, basic technology used in the EVs nowadays, and different type of batteries used in EVs nowadays. We can discuss on that also.
Okay, done. Done. Okay. So if any of you have got any comment, any question, you can write it down in the chat box. I would be looking up to those questions and I will be responding you promptly accordingly. Okay. So without wasting any time, let's just initiate the session. So before moving up with the direct technical aspect of building a vehicle or getting into this industry, I want you people to understand a bit of facts about automobile. I'm sharing my screen. I hope my screen is visible to each one of you. Could you please confirm? Could you people please confirm if my screen is visible? Okay, thank you so much for confirming. So I've got a blank PPT where I will be showcasing you a bit of data. Okay, so before starting apart this journey, we need to first understand what this electric vehicle industry is all about. So we all know this thing that when we talk about the electric vehicle industry, it is actually a subset of broader industry that is the automobile one. So if we look up into the GDP section of our India, you will find out the GDP of India is categorized into three factors or three categories. The first, the primary sector, the secondary sector, and tertiary sector. So if I talk about the manufacturing, if I talk about the serviceability of any product, it comes up under the secondary sector. Secondary sector that contributes to the huge count in Indian economy, almost 34% or more than that in Indian economy, of which automobile plays a very vital role. Very vital role. So we know this thing that automobile actually gets up into the secondary sector of Indian economy, Indian GDP. And the complete secondary sector contributes to about 34% of Indian index. It's fine. Of which the automobile also plays a very crucial role. Holistically, when you look up into this particular industry, you will find out the size of this industry is estimated to be around more than 500 billion just in India, which is estimated to be growing to about $1 trillion or even more in the coming decade. And when I talk about the automobile, we need to look up into the inception of technologies that are going to be contributed into the automobile field. So when we talk about automobile, currently we all know this thing that automobile is quite synonymous to the IC engine based vehicles. But this trend is changing. This trend is changing rapidly, and by just not, we do not have just the petrol engines or petrol vehicles or the diesel vehicles. We have got the alternate fuel vehicles coming up into the market vehicle. So I won't be saying that the IC engine is going to be completely eradicated in the coming decades. As far as I can see, in the next 3 decades, it's not possible for us to eradicate the IC engines completely. Because other than using the petrol and diesel, the alternate fuel vehicles are going to take a very vital role in the future automobile industry. So when I talk about the alternate fuels, we need to look up into the ethanol-based vehicles. 100% ethanol blended fuels are into play now. And many of the researches are currently going on. Many of the prototypes have already been built up. These are not commercially available into the marketplace, but many of the tested prototypes are already available into Indian market. When I talk about the automobile fuel industry, alternatively fueled automobile industry. Other than that, we also know this thing. There is another variation into automobile industry that comes around with the electric vehicles. With the electric vehicles. Now, when I look up into automobile, all the categories that I am defining here are on the basis of propulsion, the source of power. Here, the source of power is fuel. The source of power is fuel. Sorry. Okay. We know this thing. When I talk about the second category, that the source of propulsion is electric. In this, you will find out it's going to be fuel, but you can say these are going to be artificially created. These are not the conventional fuels that we found from the Earth's crust. Okay, so these are the mineral fuels. You can even call them the mineral fuels. We will be using the electric batteries. We will be using the ions in here. Okay, we will be using the ions in here. We are not going to use the petroleum product that is getting extincted in future. We are talking about the electric ions in here, the propulsion of electric ions in here particularly. And the third category that is getting very much popularized in the world currently is the hydrogen fuel. Now, when I talk about the hydrogen fuel, it could be burned inside the IC engine based vehicle, or it could use the electric motor, electric engine as well. It entirely depends on it, whatever the kind of vehicle that you are developing. We can go with the IC engine based propulsion, or we can go with the electric motor based propulsion. When I say I say engine based propulsion, so I'm not saying that it is going to create any kind of pollution. Hydrogen vehicle has been considered as the cleanest possible vehicle that can be developed. Even the electric vehicle constitutes to the pollution. Electric vehicle constitutes the environmental damage, not directly, but at the indirect hint. But when I talk about the hydrogen economy, when I talk about the hydrogen-based vehicle, they are considered to be the most and the superior cleaner fuel vehicles available into the marketplace. So understand this one thing, in the coming decades, you will be finding out that the automobile industry is going to shift from conventional petrol engines, diesel engines to the alternate fuel vehicles, to electric engine based vehicles, and to hydrogen fuel based vehicles. These are the three things that you will be finding out. Even when I talk about the electric vehicles, you will be finding out there are many variations, many iterations available into the marketplace. And those variations evolve to the kind of battery that we are using, the power density of the battery that we will be using. We need to look up at the life cycle of different kind of chemistries of battery. Different chemistries of batteries are needed to be looked up. Now, if I just talk about a bit of figure, the total number of vehicles that India is currently having, the total number of vehicles that the global government is currently having, and try to relate how many vehicles are going to be available into the marketplace 5 years later, 10 years later, it would be better for us to relate to this industry. So I want you people to involve into this discussion. Could you please tell me, like if I specifically talk about four-wheelers, or I'm going to include the trucks as well. The trucks, cars, passenger vehicles, vans, everything else is going to be included in it. Any vehicle with four-wheeler or greater than that. What do you think is the total volume of vehicles in India available when I talk about four-wheelers? Could you please tell me? Any data? Not 30%. I'm asking about the exact number, like numbers. 7 lakh, 10 lakh, 20 lakh, 7 crore, 1 crore. Anyone? Any estimate? Any estimate? Okay, no problem. So as per vahan.org, vahan.gov.in, Parivahan, sorry, not Vahan, parivahan.gov.in, they have got 70 million registered four-wheelers in India. 70 million registered four-wheelers in India. Okay, and when I talk about globally, it's 1.4 billion four-wheelers are currently into use, of which China is having the most vehicles, 380 or 390, I am not sure, 380 or 390 million. After that, we have got USA, and then on third position, we have got India, collaboratively sharing this position with Germany and Japan. Okay, Germany and Japan. This is what you will be finding out. The total number of four-wheelers present in the world is 140 crore, out of which 7 crore vehicles are in India. When you look up into the net ratio of vehicles as per the households, okay, total number of vehicles as per the household, you will find out only 8% of Indian household, only 8% of Indian household own a car, own a car. And if I talk about other countries, you will find out, if I talk about Italy, 89% of household has got four-wheelers. If I talk about USA, 88% household have got vehicles. If I talk about Germany, 84% households have got vehicles, have got their personal cars. So India has got a huge way, a long way to go to compete against these countries. When I talk about the number of vehicles being produced into our country, we've got a very high rank. But if I talk about a per person index, we still have a long way to achieve. But there is still a very good news. It's still a very good news. So now I'm going to shift my data from automobile to electric vehicles. To electric vehicles. Currently in the world, China is producing the most number of electric vehicles. Most number of electric vehicles. That is greater than the complete Europe combined. That is greater than the complete electric vehicle in use in the entire Europe or the USA combined. So this is what we will be finding out. 53% of the electric vehicle production in the use is just in China. And the rest is being used by all the other countries. This is something that is concerning the West. Because the complete dependency on electric vehicle when it comes to electronics, when it comes to batteries, is so much dependent on China. That's why in the last 2 to 3 years, you will find out the complete USA, UK, sorry, European countries, and even the USA are speaking about the hydrogen fuel economy. Hydrogen fuel economy. I will be discussing about this thing as well. How good is hydrogen vehicle over the electric vehicles? Okay, so if I talk about the automobile industry is growing at a pace of 6.9% globally. Globally. And it has been estimated that by 2030, the total share of automobile industry in the world economy is going to be about 6.07 trillion USD, US dollar. Okay, and it is growing at a pace of 6.9% CAGR. But if I talk about the electric vehicles, you will be finding out the CAGR of electric vehicles from 2023 to 2030 is 17.8%. 17.8%. Where you will be finding out that by 2030, the market share of electric vehicles will get to be around $1.59 trillion. A hopping $1.59 trillion. Okay. So this is what you will be finding out. So we need to look up how we can change this data, how we can work onto this particular data. Guys, just give me a moment. I am back, guys. Okay. So we were talking about this particular data. If I look up to India, you will find out in India the total number of four-wheelers, if I talk about electric, the registered total number of four-wheelers in India, electric four-wheelers in India, is mere 55,000. Like, I believe the data has been updated in 2023. It is the 2022 August data. It is going to be somewhere around 70,000 now. This is what I believe. After the electric version of Tata Nexon, it is somewhere around 70,000. Okay, electric four-wheelers in India. And I've told you that we have got a total number of 7 million, sorry, 70 million electric vehicles. The total number of four-wheelers, of which only 70,000 are electric vehicles. The good thing in India, the global CAGR of electric vehicle is 17.8%, but for India it is 32%, hopping 32%. And as per the government of India, 30% of all the vehicles produced every year would be electric, in all the variants, in two-wheelers, in three-wheelers, and in four-wheelers. These two categories are important. I'm not talking about the heavy vehicle industry because it will take more time for heavy vehicle industries to adopt the electric vehicle. But at least for the two-wheelers and four-wheelers, you will find out 30% of the production, net production in 2030 is going to be the electric. This is what the government of India claims. This is what the government of India claims. And the CAGR for this industry is 32%. Is 32%. Okay, this is what we will be finding out in future. So India is the largest growing economy when it comes to automotive in three fronts. The first front is the production, the total vehicles produced in India. Second is export. We have started to export vehicles. And the third front is net market share. Market share. In all these three fronts, you will be finding out India is the current leader in the automobile industry with 32% of CAGR. Okay, so this is what I have discussed about the electric vehicles. But if I talk about the hydrogen fuel based vehicles over which the complete European economy, the complete American economy is talking about. So currently, if I look up into the scenario globally, you will find out that the hydrogen fuel based vehicles account for only 0.1% of total market share. Only 0.1%. And it has been estimated that by 2030, this data will become 2.7%. Okay, hydrogen vehicles, hydrogen fuel vehicles, and electric vehicles. 0.1% now to 2030, 2.7%. Now you will be finding out by 2030, electric vehicle, I'm talking about a global perspective, it is going to be greater than 30%, where the countries like UK claim, countries like Netherlands, Scotland claim that they will be having 100% of electric vehicle fleet in the market. 100% conversion. Not just Britain, not just Scotland and Netherlands. Majority of the European countries are claiming this data. 100% of the vehicles. And now you will see currently 9% of the vehicles globally are electric vehicles. So please understand this thing. So if someone says that the hydrogen vehicle is going to the future, they need to look up into this data as well. In the coming decades, electric vehicle is the future. The electric battery, chemical battery based vehicle is the future, not the hydrogen fuel based vehicle. It is growing and it will grow ultimately. But at this particular point of time, electric vehicle industry is going to be the biggest and is the hottest cake available into the marketplace. Okay. Now the question comes up, how this entire shift from conventional IC engine based vehicle will happen and will go towards the electric vehicle based economy or the electric vehicle based automobile industry. How will this occur? Whenever any disruption in industry is required, first of all, we need to understand this thing. It took us more than 200 years, almost 250 years, to focus into industrial revolution. And this is the fruit of industrial revolution after 200 years, after 2 centuries, that we were able to manufacture these many good products. We were able to industrialize the weakest of economies in the world. And if any country or any economy has invested a huge count of money, huge sum of money in setting up the traditional kind of industry, it's not possible for them to vaguely and insanely change the complete structure of the industry because something new has come up into the marketplace. So it has been said, if I talk about the Indian economy, it has been said the adoption of any new technology takes about 3 decades in India. Adoption of any new technology takes about 3 decades in India. So at the time when all the Indian major manufacturers have started to develop their own production plant, their own assembly lines, invested billions of dollars into this thing, we cannot simply ask them to evoke the current processes and directly focus onto electric vehicles. It's not possible for them to set up the complete business model, to set up the complete industrial processes for electric vehicles. We need to revoke the current practices, which is not possible. So what we are doing, we are swiftly shifting from the traditional or the conventional vehicle development industry towards the electric vehicle industry. Very swiftly we are doing this thing. And when we are dealing with this thing, it's not possible for a private sector, it's not possible for the industry alone to deal with this thing. There is an infusion of capital by the government. There's the infusion of capital by the government into this particular field. The total percentage of infusion into automobile industry revamp by Indian government is greater in comparison to any other country in the world. We know those things. If I talk about UK, if I talk about USA, if I talk about China, the capital infused by them is much greater, 10 times greater, or much, sorry, not 10 times, it is still much greater in comparison to India. But whatever the cost that we are infusing into automobile industry, as per the percentage of revenue generated by this industry, it is still much greater. It is still much greater. When I talk about the automobile industry, India is still is into trade deficit. Is into trade deficit. So we need to understand this thing. Okay, so this is the biggest challenge. Like if China can do this thing, if China is producing 10 million electric vehicles every year now in 2023, why can't India do this thing? Because the capital infusion into this industry, the capital infusion into automobile industry in India is very weakened in comparison to China and USA, where USA is not focused on production, USA is only focused on technology, and China is moreover focused on production. Okay, so we need to look up into this entire paradigm. We need to understand how these things actually work. So for example, today I ask you that you need to set up your production plant, your assembly line for an automobile. What do you think? How much money is required? What is the capital that needs to be infused to set up a production line for a moderate level automobile company? What do you think? Anyone? If you need to develop a production plant generating or manufacturing 1,000 vehicles every year, what is the total cost of production plant that is required to set it up? Anyone, any idea, any vague idea, any rough idea? Yes?
It would be very high, $1 million, I think.
Just come up with any figure. Just come. I know you do not have this understanding, no problem. Just come up with any rough figure.
If we count the figure of 1 lakh units without production plant, then it must be about more than 1 crore and some loans from bank as
Okay.
well.
Okay, I got you. I got you. Thank you so much for sharing your insight into this thing. See, to set up a production plant which can manufacture 100,000 units per year of four-wheeler, you need to infuse a capital of $500 million. And if I talk about the technically advanced, the kind of Industry 4.0 on which we are currently talking about, you need to infuse not less than 1 billion US dollars to set up a production plant. Now, when you're going to set up a production plant, infusing a capital of $1 billion, do you want this complete production plant to be revamped in 3 years or 5 years? It's not possible. You want to use this particular production plant for coming 2 decades or 3 decades, and probably for 1 decade at least. And then you will try to revamp this particular technology. Okay, then you will be thinking of revamping this particular technology. So if I talk about some of the major manufacturers, major automobile manufacturers in the world, you will be finding out there is General Motors. Now General Motors is the conglomeration of many other companies, okay, many more companies. And then you will be finding out there is a Volkswagen Group. You will be looking up, there are the Ford Group, Ford Automobile, Ford Automobile. And then there are going to be many other, like we have got Honda, we have got Hyundai, we have got many other manufacturers, but these manufacturers are the biggest manufacturers in the world. We have got Daimler. Okay, you will be looking up, we have got Mercedes, you will be looking up into those things. This is what you will be finding out. Okay, this is what you will be finding out. These are major manufacturers where Volkswagen, General Motors are actually the conglomeration of many other smaller units, many other smaller companies. Okay, some of them even own BMW, Lamborghini, Ferrari. All these companies are actually owned by few of these companies only. Okay, so if I talk about Volkswagen produce more than 5 million vehicles every year, almost 5 million vehicles. This is what it produces. So if today I ask Volkswagen to revamp their complete structure, they have got enough capital to do this thing, but if they started to do this thing, their complete production facility is going to be impacted. They cannot do this thing easily. It will take them some time. So as per the Volkswagen report generated in 2013, they have said this thing that we will be revamping the complete Volkswagen production plant process in 2 decades. In 2 decades. In 2 decades. And now almost 5 million vehicles, the time when they said this thing, from there to now, almost 5 million vehicles produced by Volkswagen are on the basis of modular vehicle chassis frame. Modular vehicle chassis frame. What do I mean by this thing? I will be explaining this thing later on. There is a company like Stellantis. There is a company like General Motors. There are few other companies which are working on this model. What do we mean by this thing? I will be explaining it. Don't worry. Because this is the kind of product on which we are working on for the last 1 year. And I believe in the coming 3 years, we would be able to launch up this product into the marketplace from my company's end. So we need to look up into this thing as well. It's not easy for any manufacturer to revamp their complete production process. When you look up into Tata Motors, look up into their financial statements. You can go to their website and you can download the financial statement of Tata Motors. You will find out from 2015 onwards to 2020, they were into huge loss. Huge loss. Because in those 5 years and 6 years, Tata Motors was planning to build the future vehicles. They were planning to revamp their complete production process, their complete production line from conventional IC engine based vehicle to electric vehicle based vehicle. So this is what they have done. So in 2020 and 2021, when they have launched their electric vehicle model, they became huge. They became a huge success in India because this is the kind of vehicle that they have generated, which India needs right now. The complete production plant has been revamped. Hyundai cannot do this thing in India. Maruti cannot do this thing in India. Mahindra cannot do this thing in India. No other company in India can do this thing, what Tata has done. Because they have spent 5 years to develop this kind of production plant for their vehicle. How we create this production plant, I will be getting into these things to give you people a bit of understanding. So please understand this thing. Revamping the complete industry from the current practices to the futuristic practices require time. Require time. And it has been reported that India takes almost 3 decades to adapt any particular technology. 3 decades. And still we are leading far better than what has been estimated when it comes to India. So let's talk about the real-time data. Let's talk about the real technical aspect of designing any kind of vehicle. And in between, I will be also involving the global outlook into this thing. Okay, so let's get into this thing, the topic of concern for you people. So I want you people to be now involved up with me into this discussion. So for example, If I ask you to design any kind of vehicle into the world, and as per your understanding, when you look up into any vehicle, could you please tell me what are the major categories of the development of a vehicle? When I say this thing, let me just make my question clear. So if I say I'm talking about Tata Nexon, can you categorize all the parts of Tata Nexon? Like it has got the chassis frame, it has got the steering. So in this way, can you technically categorize any vehicle? And how can you categorize it? Anyone here? Please, I want you people to please take the attempt. Whatever comes to your mind, please speak. Okay. Now, when I talk about SUV, sedan, hatchback, these are different models. Okay, these are different models based on the styling of car. In actual, when I talk about these categories of the product, categories of the vehicle, you will be finding out all of these vehicles have got a different functional. Their purpose of development is different. Moreover, you will be finding out people are using SUVs on highways. They are using sedans in rural areas. They are using hatchback wherever they want to. So if I talk about just the purpose, it not actually justifies, practically justifies the definition. So I can just say one thing, it is all about the styling of the car. But if I talk about any car, Fahad, my question is, if I talk about any car, can I categorize different systems required to build a car?
Engine, chassis, outer body, these are things.
Okay, you
Suspension
said
system.
engine, you said
Yes,
chassis,
yes, sir.
and
Outer body,
outer body. Anyone else? I want you people to please engage, please.
Other system like steering system, the braking system,
this comes
Steering, braking,
comes under changes.
the transmission,
transmission,
Tires,
tires.
cooling system. These are
Sorry, what you
different
said?
things. Cooling system.
Cooling system. Okay. Okay. Let's look up into this thing. So whenever you have to categorize your vehicle onto the basis of systems with which it is constructed, we need to first understand the preliminary definition of an automobile. Understand this one thing, automobile is not a complete entity on its own. It's not a dedicated entity. Please remember this one thing, there's a difference between the dedicated entity and an integrated entity. So when I talk about automobile, when I talk about any vehicle, it is not the dedicated entity, it is actually the integrated entity. What do I mean by integrated entity? Any particular object, any particular entity, any particular system that is a combination of various systems that can perform solely and independently without any use case. So if I talk about the integrated system, automobile is an integrated system, and if I say it has got the steering system, it has got the suspension system. Now, if I use the suspension system is not in automobile, but in any automotive use case, in robotics use case, in any other use case, I can definitely use the same kind of system independently there. Okay, but the integration of all these systems together, when all these systems are integrated together, then we get an automobile. Then we got an automobile. So please understand this one thing, that actually whenever we talk about the automobile, it is actually an integrated entity. When I talk about dedicated entity, what do I mean by this thing? So if I talk about batteries, now battery could be regarded as the integrated assembly. Cell. Cell can be considered as the dedicated entity. Battery can be considered as the integrated entity, because as I change the number of cells, the behavior will change. As I change the quality of the cell, the behavior will change. For which I am making the changes is the dedicated entity. So similarly, if I talk about automobile, you will be finding out automobile can be mechanically can be categorized into five different systems. Five different systems. The first system is chassis frame. I'm not saying chassis. Chassis and chassis frame are two different terms. Chassis frame. The second system is steering system. The third is suspension system. The fourth is transmission system. In any order you can write it. And the fifth one is the braking system. There is no other system that is required to construct an automobile. Now you can have the HVAC, you can have the cooling system, you can have the air conditioner in your vehicle, you can have the roof over your vehicle, you can have any kind of thing. But it is only susceptible to the kind of vehicle that you are developing. It is only susceptible to the kind of automobile you are developing. So if I say automobile is only categorized, can only be categorized into five systems. And any advancement over it, like if you say, sir, I'm going to add on the elements of HVAC, then I will say it is just a portion, this is just a feature of a car. If you say that I want to implement a very good music system, it is a feature of a car. If you say that I would be having the ADAS system in the vehicle, advanced driving assistance system in the vehicle, it is a feature of a car. It's a feature of an automobile, but not the automobile as it is. Automobile is the integration of these five systems. Please understand this basic thing. These five systems. It's an integration of these five systems only. Okay, so whenever we talk about the automobile and you say that I want to change the complete vehicle category, I want to shift from IC engine based, petrol engine based vehicles to the electric engine based vehicles. Electric engine based vehicle. Where do you want to make the change? The primary change is needed to be made in the transmission system. Now, transmission system comprises your power source, the conversion unit, and your powertrain. Powertrain further comprises of your differential, your gearbox, your shafts, your tire, rim, hub, knuckle, everything else that you will be using to connect it. So understand this thing. You're converting one form of energy to another form of energy, and that conversion unit, that source is your engine, petrol-based engine or the electric engine. So this is where we are going to create the complete chain. This is where we are going to create the complete chain. So two things are changing. To understand this one thing, my dear friend, let me just add on a few more slides. Okay, so understand this one thing. You are changing two things basically in a vehicle. First is the power source, and second is your conversion unit. Now, power source. Currently, you are having the petrol and the IC engine. If I talk about the process is chemical burning. Is chemical burning. Please remember this one thing. Now, second, you will be having electric batteries. In electric vehicles, you will be having electric batteries. The conversion unit is electric motor. You can have PMSM, you can have BLDC, you can have PMDC, you can have SRM motor, you can have any kind of motor. And if I talk about the process is the electric flow, electric current, propulsion of your ions, electric ions. Third category that you will be finding hydrogen-based vehicles is the fuel cell. Plus, again motor, because it is going to be converted into process, again electric current. So this is what you will be finding out. This is what we will be finding out in any kind of vehicle. We have got a power source, we have got a conversion unit, and if we need to categorize a vehicle, this is how we can categorize it fundamentally. Now let's look up into the broader aspect. As if you people have to develop the vehicle, then what you will be doing? how will you be converting these vehicles into this particular category? So if I talk about IC engine based vehicle, and why everyone is talking about shifting from IC engine based vehicles to electric vehicles, why everyone is talking about this thing, let's look up into this particular thing. Now, if I talk about IC engine based vehicles, what you will be having? First, you will be having, the first thing that you will be having is the engine itself, which is going to have, if I talk about the number of moving parts into it, you will be saying say piston, crank, cam, flywheel, okay, and the output shaft. So these are the moving parts in my engine, So particularly, it is moving up and down, it is rotating, and it is moving up and down. Okay, these are the tapered motion and everything else is the rotational motion. Now we know this thing, all of these things are carrying a self weight. Up till now in your entire education, whenever we have done any calculation, we always consider the self weight to be the loss that is needed to be compensated. So if anything in your vehicle is rotating, or if anything in your vehicle is moving, its self weight inertia is needed to be considered. So please remember this one thing, inertia is needed to be considered. Please remember this one thing. The first loss that you will be finding out here is the rotational inertia or the motion inertia. IC engine based vehicle compared to electric motor. I'm writing these things down. Okay, rotational inertia. Here also you will be having the rotational inertia because you will be having your coil moving. If I compare these two things, if I compare the IC engine based vehicle and electric motor producing the same power, okay, so there is an IC engine producing 10 kilowatt of power, and now I am saying this particular engine is BS6 based engine or Euro 6 based engine. If I go up with the two-stroke engine, the weight is going to be much less. But if I talk about the four-stroke engine, and that too with the BS6 standards, the weight is going to be 2.5 times greater than the two-stroke engine. 2.5 times greater. If I talk about electric engine, if I talk about electric motor, for the same power rating, of 10 kilowatt, you will be finding out the weight is going to be trimmed down by 50% or more than 50%. By more than 50%. If I talk about engines which are producing 100 kilowatt of power, it is almost 70% to 80%. If I talk about axial flux motor, it is almost 70%. Okay, please remember this one thing. Okay? The weight. If I talk about just the weight of rotational parts or the moving parts of IC engine and versus the electric vehicle, you will find out electric vehicle has got 70% lesser moving parts weight. 70% lesser weight in comparison to IC engine based vehicle. It means the rotational inertia, the moving inertia of electric motor is much less in comparison to the conventional IC engine based vehicle. We need to understand this thing. Okay, please look up to this thing. Okay, now I've got a very interesting data for you. How many of you, I want you people to please give me the answer. How many of you drive car? How many of you know driving? Okay, could you please unmute yourself and say I, or you can write down in the chat box. Fahad, Suryansh, anyone else? Okay, Fahad, what car do you drive? What car do you have? SUV or XUV? Okay, so you have Duster. Okay, Renault Duster. Duster, sorry, not Duster. Renault Duster. Okay, so could you please tell me what is the mileage of your vehicle? Okay, so if I say, for example, 50 kmpl, is that fine? If I say this thing? Okay, let us consider this data. That Fahad is having any vehicle which is having a mileage of 15 kmpl when he drives his vehicle at a weight of, sorry, at a velocity of 80 km per hour, or say 100 km per hour. 100 km per hour. And for example, if I consider total weight of the vehicle at which he has measured this particular mileage is 1500 kg. If I consider this particular phenomena, if I consider this particular data, that Fahad is having a vehicle and the vehicle total weight is 1500 kg, 1500 kg, driving it, moving it at a speed of 100 kmph, and this vehicle is providing him a mileage of 15 kmpl. 15 kmpl. So you can very easily tell me how much fuel is required for 1 kilometer. So I know this thing, 1 liter is equivalent to 15 km. So I can simply say this thing, for 1 kilometer, 1 by 15 liter is the total fuel that is being consumed. Total fuel that is being consumed. I got this thing. So what I'm trying to derivate, I'm just trying to find out what's the total power consumed by Renault Duster in moving 1 kilometer compared to the potentiometer data. Compared to the potentiometer data, the electric vehicle data. Let's do this thing. So to move 1 kilometer, you have to consume 1 by 15 liter of petrol. We all know this thing that 1 kg of petrol has got 45,000 kilojoules of energy. 45,000 kilojoule of energy, 45,000 megajoule of energy is equivalent to 1 kg of petrol. So 1 kg of petrol is equivalent to 0.74 or 0.78, somewhere around this liter. 0.7, sorry. 1 liter is equal to 0.7 kg or something else. Okay, this is the density that you will be finding out, 700 kilogram per meter cube in comparison to water. This is what you will be finding out. Relative density, specific density as comparison to water. This is what you will be finding out. So as of now, I'm just considering to be 1000 for the ease of calculation. So if I say 1 liter of petrol is having 45,000 kilojoule of energy, 45,000 kilojoule is producing 45,000 of kilojoule of energy. For example, to move 1 kilometer, I can very easily predict this thing that Fahad is consuming 3000 kilojoule of energy to move 1 kilometer. For his vehicle, Fahad is consuming 3000 kilojoule of energy to move 1 kilometer. Now I've told you one thing, he is moving his vehicle at a velocity of 100 kmph. So you can very easily find out what is the power that he is actually consuming, the power consumed by Fahad. So I know this thing, it is 22 meter, 22.27, 22.7 meter per second. I can simply multiply it with this particular figure. I will be getting my data. This is the power consumed by Fahad. Okay, so this is the data, this is the power consumed by Fahad to move 1 kilometer. So this is what I just found out. This is what we just found out. This is the total power being consumed by him to move 1 kilometer. Now this is the theoretical data. This is the theoretical data. Okay, if I go with the reverse calculation, this is the theoretical data. This is the total power consumed by him. If I do not look up into any mechanical equation, if I do not look up into any Newton's laws of equation, I'm directly doing it on the basis of fuel that is being consumed. Now, when we know this thing, the only objective of my engine is to convert the chemical energy into the kinetic energy produced to my tires. Okay, but whenever you start the engine, you will be finding out heating occurs. Do you require your engine to be heated? No. It means a certain count of energy, this chemical energy of your fuel, this 45,000 kilojoule of energy of your fuel is not just distributed to kinetic energy. No, it's actually being distributed to overcome the inertia and to produce this heat, which we cannot eradicate. Which we cannot eradicate. And the third portion is mixing losses, burning losses. So these are four primary losses that you will be finding out. The only kinetic energy that you will be getting after the inertia, heat and burning losses, this a very much fraction of this particular energy is something that you will be getting. Is something that you will be getting. When you are going to solve this equation, for example, when you are going to solve this equation, you will be finding out almost 5 to 10 kilowatt, 5 to 10 kilowatt or even more than that. For moving 1 kilometer, Fahad is needing to consume 5 to 10 kilowatt to move 1 kilometer. This is what you will be finding out if you do that kind of reverse calculation. But if I use any potentiometer, if I use any torque converter meter on my tires, I will be finding out to move a duster, any vehicle having the weight of 1500 kg, any two-wheel drive vehicle having a weight of 1500 kg, moving at a velocity of 100 km per hour, you will be finding out the energy consumed by this vehicle, the power consumed by this vehicle to move 1 kilometer. To move 1 kilometer is equivalent to, on an average, is equivalent to lesser than 200 watt. When you do the reverse calculation with the IC engine based vehicle, you are finding out it comes around to be 5 kilowatt. And here when you do this calculation, what you are finding out? Only 200 watt. It means that the IC engine based vehicles are not able to utilize the complete power to be produced by the engine, or are not able to efficiently utilize the chemical energy inside the fuel. Hence, this proves the data that electric vehicles are much more efficient in comparison to IC engine based vehicles. Electric vehicle motors are much efficient in comparison to IC engine based vehicles. This is what we will be finding out. Moreover, you will be finding out electric motors produce a very high value of starting torque. The power density of electric motors is much greater in comparison to the IC engine based products, because the inertial losses in these motors is 70% lesser in comparison to IC engine based products, and in some cases it is even 90% lesser in what these IC engines are having. Is it clear, everyone? Is it clear?
Yes, sir.
Yes, yes. I'm going to get into those things as well. Okay. When I'm going to introduce the modular chassis frame structure. Before that, I will be taking up this particular topic. Okay. So we understood this particular thing. If you people have got any question, you can write down in the chat box and you can ask me. Or if there is anything that you want me to speak now. Anyone? Okay. Whenever we need to compare any product, whenever you need to compare any product into the marketplace, there is an approach to it. And we call it the FAR approach. We call it the FAR approach, the feasible, authentic, and reliable. Whenever you need to compare any product or whenever you need to develop any product, you need to focus on to FAR approach. Your product should be feasible. Your research should be feasible. Your product, your research should be authentic. It should have to be completely done by you. You're not violating any patent. You're not violating any policy. And it should have to be reliable, that you should be able to provide service, aftermarket service to the product. You would be able to come up with a reliable business plan. You would be able to come up with a reliable product that is going to last for few years. And when I talk about feasible, it only talks about the matching of need and demand. Okay, need and demand. What is your need and how we are supplying this thing? Demand and supply is needed to be justified with feasibility. We need to look up into this thing. So now we understood this thing. If we talk about electric vehicles, we know this thing that electric vehicles are going to be the future. Every major government in the world is focusing into this thing. India has got a policy FAME. FAME. So we have enrolled for FAME 1, FAME 2. We are ready to enroll FAME 3 policy and FAME 4 policy. With the FAME policy, just to make people develop electric vehicles, just to make people adopt electric vehicles, even though there are many consequences, there are many negative consequences of using the electric vehicle or developing the electric vehicles, still the government wanted to do this thing. Government wanted to adopt the electric vehicle. It has introduced an incentivization program. Incentivization program. Okay, that is the FAME policy. With it, it says any company, like for example, if you would have launched your vehicle into the marketplace back in 2015, at that time FAME 1 and FAME 2, while FAME 1 was there in the marketplace, government was literally saying any company ready to manufacture the electric vehicle, be it an MSME or be it a startup or be it a full-fledged company, government is ready to pay the 50% of the cost, 50% of the cost of the product. So it means I have developed the electric vehicle. I know this thing, electric vehicle technology is much expensive, much expensive. And even I do not have the completely fabricated production plant for the electric vehicle. The cost of electric vehicle when I'm going to launch it in the marketplace is going to be quite a many times higher in comparison to the conventional IC engine based vehicles. So what government did at that time? What government did at the FAME policy? They said if you are going to launch a product at, say, for example, 10 lakhs, and the nearest possible competition of this product in the IC engine category comes around at 500,000. Government said we are ready to pay the difference. It means the user, the end user, has to pay only 5 lakhs, and the rest of the money is going to be paid by Indian government to the manufacturer. Why? Because they want companies to manufacture the product and they want users to adopt this product. Adopt this product. So remember this one thing. Remember this one thing. Almost 4.96 trillion of carbon dioxide is released every year by the production of automobile. If all the vehicles, all of these companies will change their way to electric vehicles, it can be trimmed down to 50%. Even after taking up the impact of the indirect use of fuel. Even if I take up the impact of indirect use of fuel, this is what we will be finding out. In some countries where we have got the economy dependent on coal, it is going to be reduced by 70%, reduced to 7, like almost 30% is going to be saved. 30%. It is still a very big figure. If you can save 30% of carbon dioxide emission into the atmosphere, it is still a very big thing. That's why all the global governments are focusing on electric vehicles as of now. This is one of the reasons. So FAME 1. And then after enrolling the FAME 1 for 5 years or 10 years, government now came up with the FAME 2 policy. Now they have made it stringent because many of the players have already enrolled into FAME 1. They have taken the advantage. And now as more companies are coming up, it's not possible for the government to provide this incentive to all the companies and to all the consumers. So they have reduced discount. Now they're only providing this FAME 2 policy exemption to some of the listed and verifiable companies. So if you look up into Delhi, if you look up into all the state capitals, you will be finding out these state capitals have started to adapt their public transportation to 100% electric. It means all the new vehicles that they are currently purchasing. I'm not talking about all these states, but majority of these states in India, at least in UP, in Delhi, in Haryana, in Rajasthan, in Karnataka, in Tamil Nadu, they are doing this thing. In Telangana, they are doing this thing. All the 100% public transportation now is going to be completely electric. They are purchasing only the electric buses now. The major manufacturer of electric buses in India is JBM, Eicher, Tata, Ashok Leland. And all these companies are actually subsidized. All these companies are electrically subsidized. So as per the recent reports, Tata Motors sells an electric bus at a cost of 95 lakhs to Delhi government. To Delhi government. While it takes Tata Motors more than about 1.5 crore to build an electric bus. Then how is it doing this thing? How is it doing this thing? Their actual plan, they're actually selling the electric vehicle at 1.9 CR for private sector. The rest of this difference is actually paid by Indian government. So this is how government is incentivizing the companies and the user to develop electric vehicles into the market. Recently, an electric vehicle fleet management company in India has given an order of more than 50,000 electric scooters. 50,000 electric scooters to different companies adopting to FAME policy. FAME 2 policy. Now India has restricted FAME 2 policy just to Indian manufacturers. That is why many of the Chinese companies, many of the international companies are coming to India. So even BYD is coming to India to manufacture their product so that they can reduce the cost. Even Tesla is planning to launch their vehicle, not just launch, to develop the production plant in India so that they can exempt the tax from Indian government. Okay, so this is something that government is doing. So it has been estimated that almost 10 million jobs are going to be created. 10 million jobs are going to be created into electric vehicle industry in coming future. And now, when I talk about the electric vehicle industry, I've told you one thing. It is very difficult to existing players to shift their complete production capacity to electric. It is very difficult for them. Globally, there are almost 758 companies which control the complete global automobile production, of which 90% of the production is only made by top 50 companies in the world. Top 50 companies in the world. Do you know why? Because setting up a production plant for any kind of vehicle is very costly. It takes you more than $1 billion to compete with those companies, and it's not possible for anyone to set any small kind of company to set up this kind of plant. It's not possible. It takes about an operational cost of $10 billion to move up with this particular company. And if you look up into the profit index of automobile company, the profit index of automobile company is not even 10%, much lesser than that. The net profit earned by a company when they sell their product is less than 10%. They make the profit in the aftermarket service. And this is not what I am saying. This is what Mahindra and Mahindra has said in 2018. This is the statement made by Mahindra and Mahindra Automotive CEO. Okay, so we need to look up into this particular factor as well. It's not possible for those players. So electric vehicle industry is also creating the opportunity for startups, for MSMEs, and for smaller companies to come up with the products and gain the market size, gain the market share. Gain the market share. It allows them to come up with their products and gain the market share. Now, even when I talk about the electric vehicle, there are many of the fallacies. Or if I talk about the complete automobile industry production facility, you will be finding out there are many technical fallacies that are needed to be covered up. So there is the biggest fallacy that you will be finding out, the biggest error that you will be finding out, that the production plant facility for any automobile company is very stiff. Is very stiff. So for example, if I say this is the production plant that I have set up. Now, this production plant can only develop the vehicles having this particular size, weight, length. I would be just saying this. Okay, you will be finding out in current practices only one kind of model. Only one kind of model can be utilized to develop this particular, to be developed over this particular production line. Nowadays, in the last 1 decade, you might have started to hear out that this particular vehicle is actually built on the assembly line of this company. This particular vehicle is actually built on the assembly line of this particular company. It means this production line, this production setup, this particular assembly line can be used to develop not just one kind of product, but multiple kind of products. Multiple kind of, it means it is going to be used into for multiple vehicles, and this phenomena, my dear friends, is known as industrial belt modularity. Industrial line, production line, assembly line, modularity. Please remember this one. So current traditional practices do not allow us to have the modularity in the setup. So for example, if Jeep is being constructed, the production line on which the Jeep is being constructed, no other vehicle can be constructed over it. So for example, if I say there are only 10,000 vehicles sold every year, it means this production line is having the capacity of 100,000. But only 10,000 vehicles are being produced every year. So what is Jeep going to do in the coming years? It will stop producing this particular vehicle. And they will revamp the company production plant and will start producing some other vehicle that is available in the marketplace. Moreover, you will be finding out there are only 10,000 gypsies. For example, there are only 100,000 gypsies available into the marketplace. Or say, this is still a big number. Just say there are only 10,000 gypsies available into the marketplace. Now you want your vehicle to be serviced, but you do not want to take your vehicle to the official service center. What you will be doing? You will be going up to any local service center, and you will, now any part is need to be replaced. You will find it very difficult to find. You will be getting into very much difficulty to find that particular product, find that particular part in the marketplace, because the market is only producing the third order vendor, the second industry vendors, the auto ancillary manufacturers are only manufacturing the items that are quite much required into the marketplace, that are very popularized or are more required into the market. If the requirement of this particular product is less, you won't be finding out into the marketplace. Hence, if you are going to get this particular part manufactured exclusively for you, the production cost, the service cost will increase. The service cost will increase. So even when I talk about Hyundai, say for example, if I take the example of Hyundai, you will find out i10, i20, Eon, Grand Nios, Creta, each of these vehicles are actually built by Hyundai. But you will find out there are going to be many of the parts that are for the same use. Or even if I'm going to use the same part here on i10, on i20 or on Creta, it is going to work fine. But the design of these products for individual models are completely different. It means a part that is being used in Eon, cannot be assembled into i10, cannot be assembled into i20, cannot be assembled into Creta. What if I create the standardized product? What if I create standardized products for everything? The standardized steering system. I say to this weight category, this steering system can be used. Use it in whatever vehicle you want to use it. Okay, if I say I have got the same thing for suspension system, same thing for transmission system, same thing for braking system. Now this particular system is not just used in Creta, it is used in all the other vehicles having the same weight category. This particular principle, my dear friends, is known as market modularity, component modularity. If this is the way, you will be finding out you can take your vehicle to any service center and get it repaired, hence reducing the cost of aftermarket service for the end user. Availability of this particular product will be greater in comparison to the current standards. You will also find out today all the top selling models have got a waiting time of 6 months or even more. 6 months or more. All the top selling models. Why? The reasons are, first, the production delay. The assembly line cannot handle this much of load. Second is the raw material or the OEM part delay. As the demand of this particular product is less, the auto ancillary manufacturer, have to manufacture it exclusively for you. So either the cost will increase or the time of production will increase. But what if I say this particular ancillary, this particular part is used in all the other vehicles? It means there's a continuous flow. There are no other 10 different kind of designs on which this ancillary manufacturer is working on. Hence, reducing the part delay and the raw material delay. Hence, increasing the availability of the product into the marketplace. Availability of the product into the marketplace. Volkswagen is doing this thing for the last 7 years or about a decade. Volkswagen was able to make a 35% modular chassis frame structure. It means they have developed a chassis frame structure which is used not in one vehicle, but it is being used in different models of Volkswagen vehicles. Different models of Volkswagen vehicles. It means no different kind of assembly lines are needed to be set up. No different training of the employees for different kind of assembly lines are needed to be done. The same kind of production line is being extended. Okay, so what they have done, they have developed a universal chassis frame structure over which they can come up with 5 or 10 different kind of vehicles. So you can come up with an SUV, you can come up with a hatchback, you can come up with a sedan by using the same kind of chassis frame over which the styled body is going to be changed. The styled body, the cockpit area, the ballast area of the vehicle is going to be changed. Volkswagen is already doing this thing. And Volkswagen has reported that up till now, in the last 7 years, they have delivered 5 million vehicles. 5 million vehicles on the basis of modular chassis frame structure. Have reduced 20% of net production cost, has increased the net waiting time, reduced the waiting time by 6 months. They are readily available to the marketplace now. Reduce the delay time, waiting period by 6 months, and is saying they are producing 20% less global carbon footprint in comparison to the earlier version. When I say 35% modularity, what do I mean by this? We need to first understand what do I mean by modularity. Current production system is very stiff. So for example, if I talk about Mahindra, if Mahindra has to develop the electric vehicle, what they are going to do? They will be developing a complete vehicle, a completely different vehicle. And what if tomorrow Mahindra says, I want to come up with a different model because this model is not successful? They will be dissolving this model and will be coming up with a different model over the same production line. Or they will be setting up a completely different production line to launch a different vehicle. But what if I say, and it takes about at least 6 years to build a new product, at least 6 years. And for Indian companies, it takes about a decade to launch a new product. It means the vehicle that you will be seeing tomorrow being launched, you will get to understand the concept of this vehicle has been laid down 10 years ago or even more. Okay, so this is what you will be finding out. But if we make the complete vehicle to be modular, as I have told you, when you look up to your vehicle, it can be categorized into 5 systems. 5 systems. Now, the chassis frame. This chassis frame can be utilized into other models of the same company. This steering can be utilized into other models of the same company. This suspension can be, now this is known as modularity. If you can increase the use case of one particular model into one particular category system into other vehicles. This is known as industrial modularity. Same kind of production line can be used to develop the chassis frame of different models of the vehicle. I hope you people got this thing. Could you please confirm if you got this concept? Everyone, could you please confirm this thing? Okay, Fahad, what about others?
Got it, sir.
Okay, thank you so much. Thank you so much, everyone. Oh, again, I need to add few more slides here. really sorry. I'm really sorry. Let me just add the blank. Okay. Okay. Let's move ahead. Okay. So this is what we mean by modularity. There is one more thing. When we talk about modularity, for any integrated device, for any integrated device, if I can replace its integrated system. So for example, if I say I talk about an automobile, if I say I can categorize into chassis frame, suspension, steering, braking, and transmission. Okay. When you look up to your vehicle, all these things are very much interconnected. But what if I say I'm making a complete module of chassis frame? I make a complete module of suspension system. Nothing else is needed to be done. It is just needed to be connected, mounted over the chassis frame. That's it. A module has been created. A module. Okay. Front right, front left, rear left. Modules have been connected. So it doesn't need to take up this block and connect it with your vehicle. That is all which is required. Similarly, for the steering, I have got the module, attach it in the front or attach it in the rear and front both. Similarly, I have got it for the braking. Just attach this module to your tire. Just attach this module to your tire. That's it. For the transmission system, just attach this module to your chassis frame. What if I can do this thing? This is known as modularity. 100% modularity. So I have constructed a vehicle coming up with different modules. So this is my chassis frame module having the suspension module here, suspension module here, suspension module here, suspension module here. And just basic connections are need to be made. Then I have got my steering module connected, with which I have connected my transmission module. Transmission module. Transmission module 1, transmission module 2, transmission module 3, and transmission module 4. Motors are directly connected with the tires, okay, which is further connected with my braking module. You can see here, which is connected with my braking module, braking module, braking module, braking module, which is connected with my suspension module, which is connected with my chassis frame module. Okay, connected with my chassis frame module. Now, tomorrow Fahad comes up to me and says that I do not want this kind of suspension in my vehicle. What I simply need to do, I need to remove this module and replace it with any other component. Someone else comes say and say, I do not want this braking system. I will be just simply replacing this module. It is as easy as I am saying. It is known as 100% modularity at consumer end. It means you can purchase different systems from Amazon and directly install it to make a complete vehicle. It is not actually legal. It is not legal. But if I talk about the industrial modularity, it is legal and very much functional as of now. Very much functional. So I make a chassis frame, I make a suspension system, I make a braking system, I make the transmission system. Now, all the vehicles that you are seeing up into the marketplace are using the same kind of structure. Now see, this is a front independent system. Similarly, I have got the rear independent system. Rear independent system. Okay, front and rear. Front and rear. Both are independent to each other. No mounting, nothing is required. Both are completely, holistically acting as a riding unit. Okay, so what I have done, I have purchased the front module. I have purchased the rear module. Now I have got my mounting points. Say for example, these are mounting points. Now this mounting point is connected with my battery bed. Everything else in the front module, it means the steering, suspension, transmission, braking, is already connected to it. In the rear, everything is connected. I've just connected with the battery bed. Now this battery bed is going to act as my foundational chassis frame. Or you can say the base vehicle. This entire unit that you are looking up here, my dear friends, if I'm going to combine the front unit, rear unit along with the battery bed, is regarded as the skateboard. You just need to sit over it and you can drive it. But what if I come up with a structure over it, a roll cage over it, a space frame structure over it, a blast over it? Then I will be calling it a complete automobile. So this automobile is based on a skateboard type of chassis frame. This skateboard type of chassis frame comes up with the front and the rear module regarded as the modular electric vehicle platform. Modular electric vehicle platform. So if you look up into any major manufacturer in India or globally, you will be finding out majority of the manufacturers, they design the vehicle, but 90% of the parts, or in some cases 100% of the parts, are only assembled with the automobile maker. It means every part is manufactured or designed by any ancillary. So if I talk about Tata, you will be finding out their complete braking system is taken up from Gabri. Their complete transmission system is taken up from Dana. Their complete steering system is again taken up from Dana. Their complete transmission system, electric system is taken up from Bosch and Hinduja. This is what you will be finding out. They are just integrating chassis frame, they are making chassis frame on their own. And everything is being integrated together. So if I say, if I can outsource the suspension, if I can outsource the steering, transmission, braking, what if I say that I will be making the front module completely, the rear module completely, the complete package. Now, as per your demand, these are the mounting points. You need the higher mounting battery size, you require the lesser battery size, you require whatever the length of the vehicle that you require. You can just change the battery bed size or the foundational bed size. Just increase this thing. Can I call it a complete thing here? It's a vehicle. Can I call it a riding infrastructure? Yes, I can very much call it a riding infrastructure. So if these companies can outsource these systems, can't these companies outsource the complete riding infrastructure? Yes. So there is a company, REE. Amazon has invested more than $1 billion into this company. There is a company, Rivian. There is a company, Gossip. All these companies are heavily invested by some international governments as well as some Apple, Microsoft, Google are investing into these companies. Why? Because they know this thing, future is modularity. And all these vehicles, all these companies, they have not launched their vehicle commercially up till now. But all these vehicles are only focusing into modularity. So if I talk about Volkswagen at max is having 35% of modularity. These companies are focusing on 65% and more percentage of modularity. This is the complete overview of the electric vehicle industry. This is what you will be finding out. What people are currently doing in automobile industry. Okay, I believe you got the idea what do we mean by modularity and modular electric frame vehicles. Is it clear, everyone? Okay, what about others?
It's okay, sir.
Yes, is someone having a question? Yeah, hi, Dr. Pali. Okay, so we understood up till here. Okay, like if anyone has got any question, like Dr. Pali, you have raised your hand. Like if you've got any question, please
Okay.
unmute yourself and you can. Yeah, hi.
Yes, good evening, sir.
Good evening, sir. Good evening.
Sir, actually, I am unable to unmute, so that is the I have raised my hand,
Okay.
and it's our privilege. You are here, and you are very knowledgeable and insightful lecture, and even it is very technological as well as the recent trend. So we are highly thankful to you, sir.
Thank you
And
so much, sir. Thank
I
you so
think
much.
my student is more aware now about the EVs and the concept of EVs and modular industrial production. And this is the a new thing. And however, they are not exactly aware about these new terminologies. So we are highly thankful, and we will again see you in near future. And I will appreciate your effort. You spend more than 90 minutes continuously, and as well as the your lecture is very insightful. Every data and everything which is related to our government of India, and even there's a very big comparison between the IC engines and the EVs, as well as the new future in terms of the hydrogen economy. So, uh, it is very good question. So I am highly thankful, and we will see you again in near future, sir.
Okay, thank you so much, sir. Thank you so much. Okay, I will be just continuing for 5 to 10 minutes more, and then I will be open to all the questions. Okay. Now, Fahad has asked this question earlier. Somebody from your team has asked this thing as well. How you people can participate into this industry? So, if I talk about the Indian perspective into the complete evolution of electric vehicle technology, you will be finding out there are many incubations. There are many incubations specifically made for electric vehicle technology, renewable source energy, and sustainable mobility. Sustainable mobility. So I would recommend each one of you to go through the website of Startup India. Go to the website of Startup India. You will find out the list of all the companies which are currently working into electric vehicles, all these startups. You will find out list of all the companies which are working into not just in electric vehicles, but are also working into electric mobility. Electric mobility. See, whenever you look up into this particular industry, do not just look up into the production of vehicle, because the production of vehicle is only having a very slight percentage into the complete industry. When I talk about the logistics, the complete logistics industry of India. Sorry, what are you saying? I'm sorry, I didn't get you.
Sorry, sir, there was an interruption.
Okay, no problem. So when you look up into an automobile production industry, it is one overview, one part. You can also look up, explore the opportunities into electric vehicle fleet management. That means the last mile delivery, the last mile transportation, on corridor transportation, the highway transportation, intercity transportation. This is also one industry that opens up for us. Logistics. Now, Amazon in Haryana, like about 50 kilometers from Gurugram, there was the biggest warehouse in India in Haryana. And they have said in the entire warehouse, the complete logistics is needed to be handled only by the fleet of electric vehicles. Only by the fleet of electric vehicles. So this industry also gets opened up for us. Okay, how you can manage this thing, Then when you look up into the electric fleet management, last mile transportation, on corridor transportation, and along with that, you can also look up into deliveries, in city deliveries. In city delivery, healthcare deliveries. You can look up into the Zomato and Swiggy involvement into these things. In Gujarat, Zomato is investing almost 1,000 crores to get the electric vehicles for uh, all their delivery boys. In Delhi, already Zip, an electric vehicle fleet management company, has enrolled more than 10,000 electric scooters in Delhi NCR. More than 10,000 electric scooters. And they have not set up any individual deal. They have set up a deal with Zomato. They have set up a deal with Swiggy. They have set up a deal with the e-card, the Flipkart, the Amazon. And their delivery boys are now using the electric vehicles, electric scooters to deliver the products. So this is where you can also look up into the marketplace. So I was just talking about how you people can engage into this thing. When you will go into the website of Startup India, you will get to understand about all the companies which are working into the field of electric vehicle technology, electric vehicle development, as well as you will get the list of all the incubations working into the field of electric mobility. Now there is one thing. There are more than 10, there are 10 plus, or actually there are more than 100, which are specifically suited for electric mobility. 10 plus incubations, which are specifically suited for electric mobility. And every year they organize an event where the college students can participate, the professionals can participate. You can build your product, you can participate into the event, and if they find the product to be fine, they will be providing you a grant. Okay, the value of this grant could be anything. It entirely depends on the event that you are participating in, but they will be providing you a grant to establish or to launch the complete product. If you will be participating into MSME event, you just need to go to the website of MSME and DST, Department of Science and Technology. If you will go up to their website, and there is one more renewable ministry, just go up to their website as well. So there are 3 websites you need to look up. Every year, they also come up with their own projects. So there is a thing, DST says, even if you are a student and you are just developing a prototype, developing a project, they are ready to invest 15 lakhs rupees to any student team who are developing a product for them. If you go to a website of Startup India, even today when you go to a website of Startup India, you will be finding out there are many events that are currently going on, many competitions that are currently going on. So what they do, they take up the industrial problem statements and they pass on these questions to everybody who is enrolled into Startup India. Probably to the educational institutes, to all the IITs and NITs, to all the other level 1 institutes in India, and they ask those people to solve this problem statement. Whosoever is going to solve this statement will be getting a prize money. So you can participate into these events. So there is one incubation center in Gujarat with the name of I Create. Every year, like in January, they organize one event. This is the biggest incubation center when it comes to electric vehicle technology. I would recommend each one of you to check their website, look up to the nearest possible event that is coming up and participate in it. It will give you the real-time understanding on how you can develop the product. Then you can also look up into the website of NASCOM. NASCOM Delhi and NASCOM in Noida is helping the student teams to develop the product. So you can simply register into their platform as a student team, getting the recognition from your institute. You can participate into their event as well. You would be able to get in touch with the mobility experts. Maybe you can get in touch with the accelerators, their founders. You will get the list of mentors who will help you out in not just in developing the product, but who will also help you out in developing the business plan. Make sure of this one thing. In India or in any country, the biggest challenge is not the product. It's not the challenge. The biggest challenge is the business model. What is your ROI? Okay, this is the biggest challenge. The product, it is going to be carried on. Nobody can stop this thing. It is going to be improvised. but the business model is something that makes you get the funding. Okay, so let me just give you certain examples. So there is a program comes up on national television, Shark Tank India. So I have worked with those companies which has raised the fund in Shark Tank India. So in the very first season, there is a company, I just forgot the name of that company. The time when they came up with the product in Shark Tank India, they do not even have the real-time product. They have just got the concept. The kind of vehicle that they have showcased in Shark Tank India was even the worst product in comparison to the student teams, the vehicle developed by student teams. They received the funding. They received the funding of almost 1.5 CR at the valuation of 66.67 crore when they do not even have the product. They do not even have the expertise to build the product. That was the biggest challenge, biggest thing with their team. They do not even have the expertise to build the product. Okay, and they were able to raise this particular fund. Do you know why? Because of the business model. And as soon as they have raised the money, they have hired the engineers, they have hired the product engineers, and they developed the product. They developed the product. The product is not technically fit, but now the current valuation is more about 200 crore. About 200 crore. Okay, so this is how the startup industry works in India. I would be recommending you people. So as a student team, you should have to focus more towards the industrial outlook of developing a product. You need to understand the demand. You need to understand the requirement of the customer. Okay, so that is all from my side. I'm open to questions. If you have got any question associated with the vehicle development, associated with electric vehicles or with the motorsports, you can ask me now. Anyone? Okay, you want me to showcase some examples of modular chassis frame structure. Okay, my screen is still shared. Let me just showcase you. Let me see if I've got any images available with me. Okay, let's see. I would have showcased you the CAD design, but it will take unnecessarily too much time and it is going to strain out my system, so I cannot showcase this thing. See, this thing that you are looking up in here is the modular chassis frame structure. Volkswagen does not claim that it has made it, but it is the concept on which it is working on as of now. If you people have participated into the Auto Expo 2023, even in the Auto Expo 2023, Hyundai has come up with their own concept of modular electric vehicle frame. So look here, what we have got, the independent front shaft, you can see, and the independent unit at the rear. All that is required that you need to focus on the battery level. So Bosch, L&T, yes, L&T, Apple is already, Microsoft, all these companies are already working on these independent systems. Hinduja Group in India has also showcased the concept of independent drive systems in 2023 Auto Expo. Sustainable Auto Expo and the Auto Expo, conventional Auto Expo. They have showcased this thing. Okay, look up into other examples. See, REE, as I have told you, this is the biggest player as of now, dealing up with 90% modular chassis frame structure. So they have made this a skateboard. You can see now over this skateboard, you can come up with a truck, you can come up with a van, you can come up with any kind of vehicle. And see in the back fork, you can see all these things, all these units are the independent units consisting of tire, motor, braking system, and suspension. If I talk about autonomous steering system, rack and pinion, Verman sector steering system is not required. Even those systems are going to be steered by stepper motors. So they constitute everything. This complete tire you're seeing up here has got the implemented steering, suspension, transmission, braking. Only thing is that you need to connect it with the battery and you're ready to go. This is the modularity which I'm talking about. See, if I talk about this particular curve here, currently, if I just talk about the platform strategy, it means this thing, as what Tesla is doing. This particular thing is being developed. But now this particular model cannot be used into any other way. When I modulate, it means the different controller, different suspension can be modulated together. This is a modular strategy. Only the body is needed to be developed. And if I talk about 100% modular, it means everything, as I told you, everything can be disintegrated and can be replaced by any other system. So what if I say it has been made a standard that all the vehicles can have a same size of suspension unit, same size of suspension unit. So if I talk about, if you look up into electric chargers, if you look up into your laptop chargers, if you look up into your mobile phone chargers, their strategy is modular. Government is making it mandatory that all the vehicles, sorry, all the mobile phones are now going to come up with the C-type pin charger. Why? This is a standardized approach. A standardized approach. So that any industry would not be wasting money, would not be wasting their resources to develop different kind of strategies. So the future is the same kind of modular system is going to be adopted into vehicles. As per the current convention, it has been predicted that more than 15 decades, it will take more than 15 decades to adopt 100% modularity, which is not possible. But 60% modularity is something on which the companies are currently working on. See, 60% modularity. That this riding infrastructure can be used by any vehicle, any manufacturer. REE is not supplying this thing to any vehicle. But if you choose, you can supply this riding infrastructure to any company and they can manufacture the vehicle over it. Okay? So this is what you will be finding out. Let me just showcase you. See, this is the approach of modular. 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 The same frame is utilized to develop a minibus, is developed this kind of crossover vehicle, SUV, hatchback, a racing kind of vehicle. Same kind of frame is being used to do this thing. So this is the modularity that I am talking about. Is it clear? Oh, a compound gross rate. Like how is this in, this thing increasing? Okay, compound annual growth rate. Okay, it's just about simple interest and compounding interest, compounding rate. Okay. Is it clear? Okay. Anyone, any question? Anyone, any question?
The session
Sir,
was
your
really interesting, sir. Yes.
your lecture is very simple and recent and new technology based. So I think my student is quite satisfied from your lecture. And thank you, Vikash and Fahad, to arrange such wonderful lecture. And Vikash, please continue.
Yes. The session seemed to be really interesting, sir. I would like to thank Mr. Abhishank Jain for his depth insight, not only regarding automobile but the automobile industry. He introduced some really new terms to us, like component modularity and some government policies we were unaware of the things. We also came to know the things about which we can focus in our upcoming events and for our academic sessions as well. I would like to thank you very much for being here with your precious time and enlightening us with